We will start after some time when all the students join. We will start within few minutes. Today we are going to see the next unit, that is the retaining walls. Okay. So just a moment, I am doing the settings. Okay, so retaining wall, our next unit, unit number 8, and after that water tank. So I will give the heading first, retaining wall. I hope now my voice is loud and clear. Is it properly audible, my voice?
Yes, sir.
Okay, so we will see this, the retaining wall. So this is the design of retaining wall is a very lengthy procedure. So you have to remember the procedure for designing the retaining wall. So in the examination, cantilever retaining wall is asked. Okay, because the other retaining wall procedure is now it is much more further lengthy. So in the examination, if it is offline, then uh, in generally they ask the cantilever retaining wall design. Okay. So now syllabus, first we will go with the syllabus. In the syllabus here, analysis and design of cantilever and counterfort retaining wall. Counterfort retaining wall. These two are there for your syllabus only, out of which the question is asked on the cantilever retaining wall. Next is the about title of chapter. About title of chapter. So retaining wall is retaining wall is the soil retaining structure, the soil retaining structure, comma, the design of the design of retaining wall with IS 456-2000 is explained in detail in this chapter. Next is the central idea of the chapter. So next is central idea of chapter. For the central idea, the chapters, this chapter specifically deals with this chapter is specifically deals with design of the design of design of retaining walls, retaining walls, design of stem, design of stem from a toe slab and bottom slab and bottom slab is explained is explained in detail. Stop. The chapter mainly focus on the of stability of retaining walls stability of retaining walls against sliding and overturning sliding and overturning. Next thing is importance of chapter. Importance of chapter. This chapter this chapter deals with deals with basic basic fundamentals of the retaining wall of the retaining wall. Full stop. The standard design procedure, the standard design procedure, standard design procedure as per IS code is discussed in detail. The retaining structures, the retaining structures are very important when it comes to larger civil engineering projects. When it comes to larger civil engineering projects. Hence, its study is very important. Very important. So next thing is the chapter outcome. Next is the chapter outcome. So after successful completion of this chapter, students will be able to number one, understand fundamental concepts of retaining wall. Second, classify various types of the retaining wall. Third one, analyze and design various types of retaining walls. These are the chapter outcomes. Okay. Now we will move to our main topic, that is the retaining walls. Okay. So now further, retaining walls, you know, the structure which retains the soil is nothing but the retaining wall. We construct a large wall which retains the soil, the pressure of the soil. That wall is called as the retaining wall. So there are totally four types of retaining walls are there, out of which two types are there for your syllabus for the theory, and out of which on cantilever retaining wall the numerical is asked in the examination. So here, types of retaining wall, types of retaining wall. First, gravity retaining walls. Gravity retaining wall. Second, cantilever retaining walls. Third, counterfort retaining walls. Fourth, buttressed retaining wall. Okay. So for theory also, out of these types of retaining walls, we are going to see the cantilever retaining wall and counterfort retaining wall in detail. Okay, that we are going to see in detail. So next I will give the heading. These are the four types, out of which now we will see the description about the cantilever retaining walls. So cantilever retaining walls. So for the cantilever retaining walls, see, the cantilever retaining walls are the walls on which your stem is there, then toe slab is there, base slab is there, and just a wall is constructed. And on that wall, your soil is retaining. Okay, that is your cantilever retaining wall. So in the cantilever retaining wall, your first point is in the cantilever retaining wall, the first point is this is commonly provided retaining wall. Commonly provided retaining wall which is in the shape of an inverted T section. It is not exactly inverted T section, but it look like the shape of inverted T section. For cantilever retaining walls, it look like that. So if I draw the diagram for the cantilever retaining walls, then this is the thickness of stem at top. At top it is like this. On this side it comes straight. Then here this is the toe slab, toe projection we call this as. Here it is the heel slab. This is the thickness of base slab. I will give the name also, base slab, and this type. This is your retaining wall. Okay. So here, this is your T-shaped wall. This is T-shaped wall. Okay. So this is called as stem. I will give the naming to the different parts. This part, it is called as stem. S-T-E-M, stem. Okay. Then this part, it is called as toe slab. T-O-E, toe slab. This portion, it is called as heel slab. This is called as heel slab. Okay. So the retaining wall, somewhere here in between, there is a ground level. इथे कुठेतरी ग्राउंड लेवल असू शकते तुमची. मे बी we consider that our ground level is here. This part is above the ground level, this much of the part. Okay, that also we can here show. So, like this. This is your ground level maybe. Okay, just for your understanding, I have randomly shown the ground level. It may be anywhere depending upon the condition given in the problem. This is the T-shaped retaining wall. Okay, so here you can see this portion is called as stem. This is called as the thickness of stem at top. This portion is the thickness of stem at bottom. This is called as the toe slab, and this length is called as the toe projection. This is the heel slab, and this is called as length of heel slab. And this bottom rectangle, whatever you are seeing, this is called as the base slab. Okay, and this is the thickness of base slab. This is the thickness of base slab. So this is nothing but your T-shaped retaining wall. Okay, and here your soil retains. In this portion, there is a retaining of the soil. Here your soil retains. Here the soil will be there. So similarly, we can see the L-shaped retaining wall also. For you, T-shaped retaining wall, it is considered for the question answering also. So again, this is the stem. This is again front portion. It is like this. Okay, and then from here directly the base slab is there in this way. This type of wall. This is called as L-shaped cantilever retaining wall. This is called as L-shaped cantilever retaining wall. Okay. So again, if you give the names, this is stem, then this is hill slab. There is no toe slab here. The bottom slab is the base slab, and this it is called as L-shaped wall. This is L-shaped wall. These are the two different types of retaining walls on the base of shape. So it may be T-shape, it may be L-shape. So generally the retaining walls are of a T-shape. Okay, we provide the toe slab because it adds extra stability to the wall. Provision of the this toe slab adds the extra stability to the wall. So we will see the further points in this regard. The further points for cantilever retaining wall. Second point, its three components are its three main components. Its three main components are stem, comma, heel slab, and toe slab. I have already told you which is toe slab, which is heel slab, and which is stem. All the components acts as a cantilever. Acts as a cantilever. Therefore, this is called as the cantilever retaining wall. If you see the diagram, these all components. This is the stem. Okay, here there is no support, so it will also act as a cantilever. Here it is the toe slab. This is it will act as a cantilever, and then heel slab. Here it is the cantilever length. Here it is fixed, and this length it is act as a cantilever under the action of the forces. Then the next point, the wall is stable. The wall is stable under the action of its own weight and weight of soil and weight of soil resting on hill slab. Resting on hill slab. So the point is the wall is stable under the action of its own weight. So its own weight is acting vertically downward. And the weight of soil which is retaining on the hill slab. So here I have already told you. Here you can see here the soil is resting. Okay, soil is resting on the hill slab. That is the weight of the soil is also acting vertically downward, and weight of the retaining wall is also acting vertically downward. So the point says that the wall is stable under the action of that load of the retaining wall, under the action of the load of the retaining wall, that is weight of the retaining wall and weight of the soil resting on the hill slab. Under both these, it is stable. Now the next point, these types of walls, these types of walls are suitable are suitable to retain soil for heights not exceeding for the heights not exceeding 6 meter. Okay, so this may be the question of MCQ. Up to which meter, how much meter height cantilever retaining wall can be provided up to the range of the height. So up to 6 meter. Okay. Here in this point it is continued that in some cases either the toe slab or hill slab may not be provided may not be provided due to which wall becomes L shaped due to which the wall becomes L shaped. Okay, so this is the theory about the cantilever retaining wall. This is the theory about cantilever retaining wall. So here I have specifically told you cantilever retaining walls are of two shapes. One is inverted T and second is L shape. There are three basic main components of cantilever retaining wall: stem, hill slab, and toe slab. Every component acts as a cantilever. Okay, every component behaves as a cantilever. So this is called as cantilever retaining wall. Okay, so this is called as cantilever retaining wall, and these walls are suitable for the height up to 6 meter. Okay, for the height up to 6 meter. Now next we will see the counterfoot retaining wall. Counterfoot retaining wall. Before writing the description, we will draw the diagram first, and then we will see this. Okay. So for drawing the diagram now in 3D, the diagram should be there. Okay. So I will try to draw the exact diagram. Right. Okay. So this side, the length of the wall is like this. Here, this is the length of the wall, which is going away like this. Here also, same thing. This is the thickness at the top. To understand what is exactly the counterfoot, this diagram is necessary. So that is why I am drawing this. So at this point here, so the counterpart is like this. From this point, okay, and this slab, I will continue this slab. It is going like this. Here the thickness of slab is continued. The slab. Okay. So here at this point, like this. And then now counterpart, this part it is called as the counterpart. Now whatever I am showing with this red, this part, this is known as the counterpart. Known as the counterpart, and it will continue like this only. From here, continue like this. Next counterpart will be there. Next counterpart will be there. The same thing is there. Next counterpart may be at this level. Here somewhere. Okay, here you will get the next counterpart. Similarly, next thing is there. So this is the diagram of this retaining wall. This is the diagram of this retaining wall. So here I will show it like this, so that we can say that we have shown only the one section for the understanding purpose. So now I will give the name to the different components of this counterpart retaining wall. This is called as upper slab or upright slab. It's called as upright slab, or also called as upper slab. Okay. This portion that is called as a stem. This portion is called as stem. This is your, this portion is hill slab. This is hill slab. Now if I draw this line parallel over here, parallel to this line, like this. Okay. So this portion, whatever created over here, this is called as toe slab. So this is your toe slab. This is toe slab. Okay. And now this is called as counterpart. This portion, which is called as counterpart. This is called as counterpart. So this is the additional thing which is placed over here. जी रिटेनिंग कॅन्टिलिव्हर रिटेनिंग वॉल मध्ये नाहीये आणि काउंटरफोर्ट मध्ये आहे, तेच फक्त एवढं एक ऍडिशनल गोष्ट. दिस इज द ऍडिशनल कॉम्पोनंट. ओके, which is not there in cantilever retaining wall, but it is there in counterfort retaining wall. This distance this distance, if you see this much of distance, this is nothing but this is the depth. So this is the depth of hill slab, okay, or base slab you can say. This is the diagram of counterfort retaining wall. This is the diagram of counterfort retaining wall. I hope now it is clear to you how the counterfort retaining wall look like. Okay. And what the portion of the hill slab it is there, it is totally filled with the soil. So previously we have only drawn the cross section. Now I have tried to draw the 3D. Hopefully you will understand now better. So now moving further in this regard, we will write some points for this counterfort walls. So counterfort walls, counterfort walls are cantilever walls, cantilever walls strengthen 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 with strengthen with strengthen with counterforts counterforts strengthen with counterforts which are monolithic monolithic with the back of the wall slab and base slab. Okay, so these are counterforts. These counterforts are monolithic with this wall and this base slab. It is casted together. While casting the wood wall and casting this slab, this is cast. So it is the monolithic. Second point, the counterfort, the counterfort act as act as act as tension stiffener, tension stiffener and connect connect the wall slab and the base slab and the base slab wall slab and the base slab to reduce the bending and shearing stresses, bending and shearing stresses. So the counterforts are provided, those are act as a tension stiffeners between the wall slab and base slab, and due to which the bending and shear stresses are getting reduced. Okay. Bending and shear stresses are getting reduced. The next point, the counterfort used for counterfort used for high walls high walls with heights with heights greater than greater than 8 8 meter to 12 meter. This can be also the question of the MCQ. So when we are going to provide the counterfort, when it's when it is above 8 to 12 meter, okay, then we are going to provide this counterfort. Okay, the next point, the counterforts are provided. Counterforts are provided provided at intervals of at intervals of about 3 meter. So after every 3 meter, the counterforts are provided. It will also give the support to the wall slab, and it will also connect the wall slab to the base slab, so that there will be the reduction in the bending and shear stresses. So there will be a reduction in bending and shear stress. Okay. So here one more point which is to be noticed in this. So here the vertical slab and hill slab hill slab acts as a continuous slab. Acts as continuous acts as continuous slab, while toe slab acts as cantilever slab. Okay, while the toe slab acts as a cantilever slab. So this is what is the theory of this counterfort retaining wall. Okay, so we have seen the theory of first of all we have seen the theory of this cantilever retaining wall. After that, now we have seen the theory of counterfort retaining wall. Now, for general terminologies, where we are going to use the which symbol for which height and what symbols we are going to use for that, I will draw one diagram so that it will be easily understood to you where which symbol we are going to use. Okay, that will be clear to you. So now I will draw the diagram first. Is the stem. So this is the wall which we are. Once this diagram is complete, then I will tell you which notations we are going to use for what point, so that you will get familiar with this. And this is the depth. I will draw this line up to this point. Then I will connect this. At the top, stem is there, the length. Okay, so it is joined like this. So now this is the typical section of the retaining wall. Okay, now suppose I will draw the ground level. So you can imagine that suppose at this level your ground level is there here. This is your ground level. This is the ground level. Take it. So only this much portion of this wall, only this much portion of this wall, this portion is below the ground and the remaining portion is above the ground. This is ground level. GL. This is the ground level. Now this height below the ground level, it is denoted by letter YM. Okay, so this height below the ground level, this height from this point, from here to here, this height, whatever this height, below the ground level, whatever height is there, it is denoted by letter YM. Okay. And above ground level, it should be like this, no? This height. This is nothing but your YM up to this point. Okay. And then here, this height, this we are going to use the notation H2. This is the height of retaining wall above the ground level. The height of retaining wall above the ground level. Okay. And total height, this total height from this point. So this is your H1. So this total height from this point, if I measure to here up to this point, total height. So this total height will be, this is taken as H1. The notation I am going to use is H1 for this total height. Then B is the width. So this width, this is called as the width, base slab width, B. This is called as B. Okay. Now this is the this side. This is the heel slab projection, and this is the toe slab projection. Okay. Heel slab projection and toe slab projection. It may be gone like this on that side also. So here it is the toe slab projection. This side, this is called as toe slab projection. This is the heel slab projection. Okay, heel slab projection. So here some formulas are there that need to be remembered. So this Ym is equal to what? It is depth of a retaining wall depth of retaining wall below ground level. Below ground level. Therefore, this Ym it is calculated as Q0 by gamma. Okay, Q0 by gamma into K square into Ka square, where your Q0 is the safe bearing pressure of the soil. Okay, Q0 is the bearing pressure, gamma is the density, and Ka is the coefficient of active earth pressure. K is the coefficient of active earth pressure. Here I can write Q0. Q0 is nothing but safe bearing capacity of the soil, Q0, which is equal to safe bearing capacity of soil, then gamma it is the density of the soil, gamma it is density of soil, and Ka this is coefficient of active earth pressure. Okay, you can say coefficient of earth pressure. If Kp is there, then coefficient of passive earth pressure. Ka notation is there, then coefficient of active earth pressure. Okay, समझते क्या? Is it clear? Or we can call this total height जी आहे ती Ym plus h2 is equal to h1. total height ला आपण h पण म्हणू शकतो. Okay, we can call this total height as a h. We can call it as a h also. So now this is the formula to calculate the depth of the retaining wall below the soil. By using this formula, you can calculate the depth. So based on this, moving further, then H1, I have just written over here, H1 is equal to what? It is Ym plus H2. Here you can see clearly. If you add H2 and Ym, you will get H1. H1 is the total height. Then B is the width. See this B is this horizontal dimension B. That is the length of the base slab B. So it is calculated as B is equal to, it can be taken as 0.48 H1 to 0.56 H1. This is the range to calculate the B. This is the range to calculate the B. Okay. Then length of toe slab. So length of toe slab. This is also called as toe projection. This is also called as toe projection, and it is taken as 0.3 B. Once you calculate this B in the above step, then if you take 0.3 of that, then you will get the toe projection. 0.33 or 1/3, whatever you want, you can do. Either you do 1/3 or take it as a 0.3 B. Okay. So now thickness of stem. Next is the thickness of stem. So at top, the minimum thickness should be 200 mm. Okay. So at the top, the minimum thickness should be 200 mm. But at bottom, it must be h1 by 12. Thickness is h1 by 12. Okay. Then how to calculate the earth pressure? This is the important formula. This you have also learned in geotech. Earth pressure at bottom of the retaining wall. Earth pressure at bottom of retaining wall, it is calculated as K into gamma into H. Okay. K into gamma into H. That is the earth pressure. This is the formula, K into gamma into H. Then how do we calculate the coefficient of active earth pressure? Coefficient of active earth pressure. It is calculated as coefficient of active earth pressure K, which is equal to 1 minus sin phi. This formula is already known to you. Divided by 1 plus sin phi. It is calculated like this. Coefficient. What will be the maximum force? Maximum force किती असणार आहे तुमचा? So what is the base of earth pressure? K into gamma into H. So area of that triangle K into gamma into H square येणार. K into gamma into H square. कळलं का? Maximum force or maximum earth pressure. Maximum pressure. Okay. The maximum force, if you want to calculate maximum force, किती असणार आहे maximum force? Now, if you see the retaining structure, soil is retained in this shape. This is the triangular shape. Okay, here the retaining will be there. This is the structure. This is the soil pressure. Now this will act vertically downward through CG from here. Yeah. So if I calculate the area of this area, then I will get the what we can say maximum pressure. So area is half into base into height. So base is this dimension. This is the base from this point to this point. This is the base B. This is the base B. So half into B into H now. So this is H. Okay. So this is H. Then if I calculate half into base into height, that is H1. Now if you further simplify this area is equal to this B is nothing but it is Ka into gamma into H. If H1 is there, then H1. If I put the formula, it is half. Okay. The base is Ka into gamma into H1 and then into H1 square into H1 again. Okay. So the maximum pressure is maximum force is, if I calculate this maximum force, then that maximum force is 1/2 K into gamma into H1 square. K into gamma into H1 square. This is the force. So these are some values we need to consider while solving the problem. Okay. So you just wait for 2 minutes. I will come back within 2 minutes. But you should see whatever I have given right now, whatever we have taken in the lecture right from the start. You just go through it. I will come within 2 minutes. Okay. Okay, so here now this is the maximum force. Okay, and if I want to calculate the overturning moment, okay, overturning moment, then how should I calculate overturning moment? Now see, this is the earth pressure which is written. Now this is the force. What is the value of force? It is half into K into gamma into H1 square. This value we have already calculated. This value H1 square gamma Ka into half. This force we have already calculated right now. This is the area. Okay. So you know that what is the overturning moment we will calculate about this point. Okay, overturning about hill. So here about tau we calculate, so we take it on the left hand side, the moment. So here this angle is 90 degree. This angle is 90 degree. So this force is acting like this, K into gamma into H. Okay. So now we will take this overturning moment and we will calculate this moment as it will be if the wall is horizontal. If the wall is horizontal, then it will also act horizontal. So here the maximum overturning moment is equal to, it should be like this, huh? This direction. Okay, I will show this will act on the wall from the centroid. This will act on the wall. This force. This is your force. So this distance must be h by 3, h1 by 3. So its moment will be half into Ka into gamma into h1 square into h1 by 3. So this is the overturning moment. The notation for this is m0. For overturning moment, the notation used is m0. Okay. So now with this introduction, we will move for the numericals. We'll take the numerical based on this. Okay. Just 1 minute. We'll take the numerical now. Design a cantilever retaining wall to retain an earth embankment with with horizontal top with horizontal top of 3.5 meter above ground level. Above ground level. Okay. So from ground level, the height is 3.5 meter above ground level. The density of Earth is, the density of Earth is, that is soil density, it is given 18 kilonewton per meter cube. 18 kilonewton per meter cube. Okay, comma, angle phi is equal to 30 degree and SBC, safe bearing capacity of soil, safe bearing capacity of soil is equal to 200 kilonewton per meter square. To stop, take the coefficient, take the coefficient of friction, take the coefficient of friction between soil and concrete is 0.5, is 0.5. Full stop. Adopt M20 grade concrete, adopt M20 grade concrete and 415 steel and Fe415 and Fe415. So this is the numerical which is given. Now we will read the given data. So that you need to design the cantilever retaining wall. The horizontal top is 3.5 meter, okay, above the ground level. So above the ground level, the height is 3.5 meter. It is given above the ground level. They have mentioned specifically. Density of the earth is, that is density of soil, gamma is given to you. Density 18 kilonewton per meter cube. Phi is given to you 30 degree. So a safe bearing capacity, okay, Q0 200 kilonewton per meter square. Coefficient of friction value of mu is given between soil and concrete is 0.5. Grade of concrete is given M20 and Fe415. So this is the given data. So first of all, we will write what is given. So here, first, here H2 is given to us. H2 is equal to how much? 3.5 meter. H2 means, here you can see H2. I have see. This height is given above the ground level. Height is given as 3.5 meter. So above the ground level, the height of retaining wall, we are using the notation H2. Here you can see above the ground level, we are using the notation H2. So above ground level height is known to us. So 3.5 meter. Then gamma, density of soil 18 kilonewton per meter cube. Then what is given? Phi, it is 30 degree. Then Q0, safe bearing capacity. Safe bearing capacity is 200 kilonewton per meter square. This is the safe bearing capacity. Mu is equal to 0.5 FCK 20 Newton per mm square. Fy 415 Newton per mm square. So this is the given data. Now by using this data, we need to design the roof retaining wall. Okay. So first of all, our first step is we will calculate the coefficient of active earth pressure. We will calculate the value of Ka first. So here I will write coefficient of active earth pressure Ka. So therefore KA is equal to, it is 1 minus sine phi divided by 1 plus sine phi. Phi is 30 degrees, so put the value equal to 1 minus sine 30 divided by 1 plus sine 30. So what is the answer? Sine 30 means 0.5, no, half. So 1 minus half, 1 by 2. And here 1 plus sine phi is 3 by 2. 1 plus 0.5 is 1.5. So 3 by 2. 1 by 2, 3 by 2. So 2 will get cancelled. It will be, see, this will be, it is like this, 1 by 2 divided by 3 by 2. So 2 will get cancelled. It will remain, it will be 1 by 3. Is it right? 1 by 3 will be there. This is the value of Ka. This 2 will get cancelled. Now depth of retaining wall below ground level. Okay. Second step is this is your first step. Second step, depth for retaining wall. Depth, I will not give the names, numbering. If you want, you can give. Depth of retaining wall. Depth of retaining wall below ground level. Below ground level. It is denoted by letter YM. So the YM is equal to, what is the formula for this? It is Q0 by gamma into Ka square. If you put the value, Q0 is 200 kilonewton per meter square, gamma is 18 kilonewton per meter cube into K is 1/3. The value of K is 1/3 and its square. So solve it and let me know the answer. Calculate and let me know the answer. So the answer is 1.23 meter. So we will take it as a 1.25 meter. Okay, 1.25 meter. Now, this is the depth of retaining wall below the ground level. So below ground level ची डेप्थ तुम्हाला माहिती आहे. अबाव ग्राउंड लेवलची पण डेप्थ माहिती आहे. डेप्थ म्हणजे हाईट म्हणायचं मला बरं का. हाईट ऑफ रिटेनिंग वॉल बिलो ग्राउंड लेवल म्हणा. डेप्थ नाही तर परत तुम्ही कन्फ्युजन मध्ये जाताल थिकनेस आणि डेप्थ मध्ये. सो इथं सरळ असंच म्हणा तुम्ही हाईट. ओके, हाईट ऑफ रिटेनिंग वॉल बिलो ग्राउंड लेवल. ग्राउंड लेवलच्या खाली किती हाईट आहे आणि ग्राउंड लेवलच्या वर किती हाईट आहे. व्हॉट इज द हाईट अबाव ग्राउंड लेवल अँड हाईट बिलो ग्राउंड लेवल. सो फ्रॉम दिस नाउ वी विल कॅल्क्युलेट द टोटल हाईट. So total height is equal to, so above ground level height is 3.5 plus below ground level height is 1.25. What is the answer? .75. Okay, so it is 4.75 meter. Okay. So now next is the now width of base slab. Okay. So width of base slab. width of base slab, that is B, small b. It can be calculated as 0.48h to 0.56h. To calculate both, therefore B is equal to 0.48 into h is 4.75 to 0.56 into h is 4.75. Let me know both the answers. B is equal to 2.28. This is 2.28 meter to next 2.66 to 2.66 meter. So we will choose where in between these two ranges a good round-up value. Okay. So therefore we will choose B is equal to 2.28 to 2.6 च्या मध्ये असायला पाहिजे value. So I will choose 2.5 meter. I will choose B is equal to 2.5 meter. Okay. So here next is the length of toe slab. Length of toe slab. So the projection which is in front, it is 0.3 into B, which is equal to 0.3 into 2.5, which is equal to how much? 0.75. This is 0.75 meter. Okay. So now the thickness of retaining wall or the thickness of stem at bottom. Here, this formula we are going to use. This thickness of stem. Okay. Now up to this point we have completed. हे बघा हे सगळं तेच आहे. I already given you the steps. First we have calculated this. YM we have calculated. Then after that we have calculated H1 total height, then B width, then length of toe slab, that is toe projection, and now thickness of stem that we are calculating. Thickness of stem at bottom, because at top it should be minimum 200. At top it should be minimum 200. So at bottom, which is equal to H1 by 12 equal to 4.75 by 12. How much it is? 0.395. So 0.395 means 0.4 meter, which is nothing but it is 400 mm. 400 mm. Okay. Now I will draw the diagram once again and I will show you all these dimensions in the diagram. So Okay, so the dimensions are this we have assumed, and this should be minimum standard value 0.2 meter. At top, the thickness of stem should be minimum 200 mm. Okay, minimum it should be 200 mm. And here at this bottom, this we have calculated at thickness at the bottom. This is the thickness of stem at bottom. This is 0.4 meter. This is 0.4 meter. Then this length, this is the toe projection. This is 0.75 meter. This total is already known to us. This total distance B at the start we have calculated that it is 2.5 meter. Okay, and then what is the total height? Total height is 4.75 meter. Okay, so if you see this total height from this point up to here, this total height, so this is 4 4.75 meters, and this you can calculate whatever remaining is there now. This distance, this you can calculate easily. Okay, you know total is 2.5. From that you can subtract 0.75. What is the answer? 1.35. Okay, so it is 1.35. 1.75 minus 0.4 again, so this distance remaining it is 1.35. Okay, so below ground level you know that what is the height, above ground level you know what is the height. Okay, so now we will provide this thickness of the retaining wall, whatever thickness we have provided here, thickness at the base of the stem, same thickness we are going to provide for the slab also. Okay, so for base slab we are going to provide the thickness as 400 mm. Okay, for base slab also we are going to provide the thickness of 400. Whatever the here we are going to provide, same we are going to provide to the base slab. It same should be provided. It is mentioned in the ISO, but it should be same. Now this is the diagram. Now we will take the stability checks. Okay. Now we will take the stability checks. So let me know how much is this height. ये height कितनी हो गई फिर from this point here up to this point. What is this height? This height is 4.35 no minus 0.4 करना फक्त. Okay, 4.35. Now the next step is we are going to take the stability checks, and in that stability checks we are going to take the moment at this point for all the forces to check the stability. Okay, to check the stability we are going to take the moment of all the forces. Okay, so here okay, so now I will make one table so that it will be easier for you to understand. So in the table I will write here parts, then weight in kilonewton, weight in kilonewton, then the distance x meters, and stability moment ms is the stability moment which is in kilonewton meter. Stability moment ms. So this is now stability check. You give the heading to this as a stability check. Okay, so this is the table. Now what I'm going to do, see this diagram. I will divide this diagram into the number of known shapes, okay, into the known areas. So here, if I drop perpendicular from here, this point, so it will become triangle and rectangle. So that is it is easier for us to take the moment at the assigned point, which is shown over here. So now I will assume that this is my W1, this is my W2. Okay, I will call this as a W3. This last one is W4. Okay, so these are the weights W1, W2, W3, W4. So now further, here first W1. Here is the first W1. So weight in kilonewton. So what is the weight? So W1 you can see now. This distance, this is 1.35. This is 4.35. Assume the length of the retaining wall is 1 meter. Assuming the per meter length analysis. Okay. So length of the retaining wall is 1 meter. Then if you see this W1 is situated over here, what is the cross-sectional dimension over here? This is 1.35. This is 4.35. So it is 1.35 into 4.35. Okay, cross-sectional dimension into now W1 is the area where soil is there. In this area, what here concrete will not be there. This is the retaining area. So soil should be present over here in this area. So here you can multiply it by 18. Okay. And this will be come in kilonewton per meter, but we have assumed 1 meter length. So for 1 meter, if you multiply it by 1, you will get it kilonewton. You will get the answer in kilonewton. If you multiply it by 1. Okay. So now this is the force. So what is the answer of this? 1.35 into 4.35 into 18. So it is 105.70. This is 105.70 kilonewton. Now see the distance, x meter. Distance from that point also we need to find out. So from this point, what is the distance of W1? So here you can see W1 will act. This is the rectangle. This is 1.35. This is 4.35. So this is the rectangle. So CG of the rectangle will be at the center. Centroid is at the center. So if this total is 1.35, so the center of 1.35 will be it is 0.675. So center is 0.675. So here somewhere the force is acting. Point load 0.675. Okay. So now its distance about this point. So it will be 0.75 plus 0.4 plus 0.35 by 2. Okay. So here 0.4 plus. Calculate the distance now. So it will be 0.75 plus 0.4 plus 1.35 by 2. So calculate it now. 2.5. 2.5 नीट कॅल्क्युलेट करा बघा. 1.825. Okay, this is 1.825. Now moment, multiply this force into distance, so you will get the moment. What is the moment? What is the answer? Multiplication 192.90. Okay, so this is 192.90 kilonewton meter. So this W1 is over here. Similarly, we will go for W2, W3 and W4. I hope now you understood now what we need to do. So here we'll go for W2 now. W2 is equal to, see where is the W2? So this is the W2 here at this point. This is our W2. This is again rectangle. So rectangle, so this dimension is 0.2 and this total dimension is 4.35. So 0.2 by 4.35 is the dimension of the rectangle. Then the centroid, the force of this, what we can say, rectangle, the centroidal force will act from the center. So this is 0.2, center will be at a distance of 0.1. So 0.1 plus this is 0.2 plus 0.75. That will be the distance. Okay. So here I will write it is 0.2 into 4.35 into, now this is concrete, so multiplied by 25. कितीने मल्टिप्लाय करायचं 25 ने. हे कॉन्क्रीट आहे, हे जे आहे ना हे कॉन्क्रीट आहे, आतलं सॉइल बाहेर आहे. ओके, so it is, this is the, what is the answer? $21.75 force. Okay, $21.75. Now calculate its moment from this point. Point 75 plus 0.2 plus 0.2 by 2. What is the answer? 1.05. Okay, this is 1.05. Now calculate the moment, stability moment. So 22.83. Okay, so this is 22.83. So now W3, do the same thing with W3. So W3, here you can see this is the triangle. This distance is 0.75. So 0.75 plus 2/3 of base, because this angle is 90 degree. So if this is 0.2, this will be 0.2. So this remaining will be 0.2. So 2/3 of 0.2 plus 75. Okay. So W3 first, here you should see this is the rectangle. So half into base into height. So height, this height is 4.35. So half into base is point 0.2 into height 4.35, and concrete is there, so multiplied by 25, which is equal to, what is the answer? 10.87. Okay, this is 10.87 kilonewton. Now again calculate the centroid, where it is situated. So the centroid is 0.75 plus 2/3 of 0.2. What is the answer? 1.67. Okay, so 1.67. Now calculate the moment. What is the answer? Do it now. 0.88. Okay. Distance is 0.88. Okay, so this distance is 0.88. 0.88. Now calculate the moment. Nine 9.56. That is 9.56. So 9.56 is the moment. Then finally W4. All this we are doing for taking the stability check. W4. Where is W4? So this is bottom rectangle. So it is 2.5 meter wide and its 0.4 meter is the thickness. So it will be 2.5 into zero point 0.4. What is the load? It is 2.5 into zero point 0.4 into 25. You will get the load. It is 25 kilonewton. So this is 25 kilonewton. And then its centroid, it is 2.5 by 2, which is equal to 1.25 meters. So calculate the moment. What is the moment? $31.25. Okay, so this is 31.25. Now we will take the summation of all of this. So here we'll take the summation now. So add all these moments. Let me know the answer. Two 256.54. This is 256.54 kilonewton meter. This is the summation of all moments. Now all add weights. This is summation M S. Okay, stability moments. All add all the weights. What is the answer? Add all the weights. Weight in kilonewton. It is 163.32. This is 163.32. Okay, so this is summation W, all weights. Like all weights. Now calculate maximum lateral pressure. Next step is calculation of maximum lateral pressure. Maximum lateral pressure. I have given you the formula of this. What is the formula for maximum lateral pressure? Here is the formula. So here, half into Ka into gamma into H1 square. Here the formula is given. Half into K into gamma into H1 square. So here half into Ka into gamma into H1 square, which is equal to half into 1 by 3 into K is 1 by 3, gamma is 18 into H1 square is 4.75 square. So let me know the answer. What is the answer? $67.68. Okay, so this is 67.68 kilonewton. Now calculate overturning moment. Overturning moment, which will be in opposite direction to stability moment, M0. How to calculate the moment? this moment, the formula is multiply that by h by 3. See, this is the formula. Half into k into gamma into h1 square. This is the force multiplied by h1 by 3. Okay. So here I will write half into Ka into gamma into h1 square into h1 by 3, which is equal to, it is 67.68 into 4.75 by 3. So therefore, m0 is equal to 107.17. 107.17 kilonewton meter. Okay. Now we will take the check for, this is the stability analysis. So in the stability analysis, what we have done, we have calculated total load 163.32. We have calculated the MS, that is the stability moments we have calculated. And now this is the overturning moments. See, stability moments and overturning moments are in opposite direction always. Now we will take the check for overturning and sliding. Okay. So first of all, check for overturning. So factor of safety of overturning, it should be greater than 1.4. Okay, FO means factor of safety for overturning. It should be greater than 1.4. So we will calculate that. FO is equal to, what is the formula for this? It is 0.9 into stability moment MS divided by M0 overturning moment. This is the formula. So if you put the values 0.9 as it is into MS we have calculated. What was the answer? It is 256.54 stability moment, and divided by, as unit is same, there is no need to multiply it by 10 raised to 6 because the unit is same. Okay. So calculate the value of overturning factor of safety. And this clause is given in the IS code. Okay, so this is given at IS 456-2000, clause number 20.1, page number 33. This is given in the IS code. So now, what is the answer? What is the answer? It is 2.15. So this is 2.15, which is greater than 1.4. 1.4 पेक्षा जास्त यायला पाहिजे ओव्हरटर्निंग मध्ये सेफ हवा असेल तर. Okay, so which is greater than 1.4. So this is safe in overturning. Safe in overturn. Okay, so the remaining part we will cover in the next lecture. So this is the stability checks which we are seeing right now. We have taken the check for overturning. After that, we will take the check for sliding also. So today we will stop over here. So I will take your screenshot of the attendance. So please wait. Okay, now you can drop your roll number into the chat box and you can leave the lecture now.